Hello everyone, welcome back to the channel. Today, we are diving into the construction world and talking about something that's often overlooked but crucial: cement. Cement is like a binding material in construction, the glue that holds everything together. It's not just a powder in a bag, it's a team player that unites different elements to create solid structures. Think of it as the mediator, bringing sand and gravel together to form a strong foundation. Now, there are different types of cement, and they can be classified based on their source. First, there's natural cement, which comes from specific geological deposits of limestone mixed with clay. It was a big deal in the 19th century but has become less common. Then, there's artificial cement, also known as Portland cement, which is manufactured through a controlled process and is the standard in modern construction. The name, Portland cement, comes from its resemblance to a type of sandstone found in Portland, UK. Cement, particularly Portland cement, which is the most common type, possesses several important properties that make it suitable for various construction applications. Here are some of the key properties of cement. Setting and hardening. Cement can set and harden when mixed with water. This property is crucial for forming a solid, durable structure. The setting time can vary depending on the type of cement used. Strength. Cement provides compressive strength to concrete and mortar when it cures. The strength of cement-based materials increases over time as the hydration process continues. Durability. Cement-based materials, when properly mixed and cured, are known for their durability and resistance to weathering, chemical attack, and wear and tear. Adhesion. Cement has good adhesion properties, allowing it to bond with various aggregates, such as sand and gravel, and other construction materials like bricks and stones. Workability. Cement-based mixes can be adjusted for workability by controlling the water content. This property allows for the construction of different shapes and structures. Heat resistance. Cement can withstand high temperatures, making it suitable for fire-resistant applications. Low shrinkage. Properly cured cement-based materials exhibit low shrinkage, which helps prevent cracking and ensures structural integrity. Chemical inertness. Cement is chemically inert when cured, which means it does not react with most other substances, making it compatible with various construction materials. Versatility. Cement is versatile and can be used in a wide range of construction applications, from building foundations to bridges, highways, and decorative elements. Setting time control. Depending on the type of cement and additives used, setting times can be controlled to suit specific construction requirements. Color. While most cement is gray, white cement is also available for applications where a pure white finish is desired. Additionally, colored pigments can be added to cement for decorative purposes. Sulfate resistance. Some cement types are formulated to resist sulfate attack in environments with high sulfate content, such as soil or water. Low alkali. Low alkali cements are used to prevent alkali aggregate reactions, which can cause cracking and degradation in concrete. Eco-friendly options. Some modern cements are formulated to have a lower environmental impact by reducing carbon emissions during production. Applications of cement in construction. Concrete production. Cement is a key ingredient in making concrete. When mixed with water, sand, and aggregates, it creates a versatile building material used for structures like buildings, bridges, roads, and sidewalks. Mortar. Cement mixed with sand and water forms mortar, which is used for bonding bricks, stones, and masonry units in walls and arches. Stucco. Cement-based stucco is used for both aesthetics and protection on building exteriors. Grout. Cement-based grout fills gaps between tiles, making surfaces like floors and walls water-resistant and visually appealing. Foundation construction. Cement is used to create stable foundations by pouring concrete footings or slabs to support structures. Road construction. Cement is essential in road construction, used for both concrete pavement and soil stabilization in road bases. Bridge building. Cement provides the strength and durability required for constructing bridges to withstand heavy loads and harsh conditions. Dams and reservoirs. Large dams and reservoirs rely on massive amounts of cement to create robust structures for water storage and control. Tunnels. Cement ensures tunnels can withstand the pressure and conditions underground. Decorative applications. Cement is used decoratively for sculptures, garden features, and architectural details. Pipe and precast concrete products. Cement-based pipes and precast products serve various purposes, including water supply, drainage, and industrial applications. Underwater construction. Specialized cement formulations are used for underwater structures, such as foundations in marine environments. Repair and restoration. Cement-based materials are vital for repairing and restoring existing structures, including crack filling, surface patching, and reinforcing aging infrastructure. Cement's versatility, strength, and durability make it a foundational material in modern construction practices. Chemical constituents of Portland cement. Portland cement consists of several vital chemical components, each with a specific role to play in its composition and behavior. Lime, making up approximately 60 to 67% of cement, it acts as the primary ingredient, forming the foundation of cement's composition. Silica, accounting for roughly 17 to 25%, silica serves as the backbone, providing strength and durability to the cement mixture. Alumina, comprising 3 to 8%, alumina is like a dependable supporter, contributing to the overall structure and stability of the cement. Iron oxide, found in quantities of about 0.5 to 6%, iron oxide is akin to a coloring agent, giving cement its characteristic grayish color. Magnesia, at levels of 0.1 to 4%, magnesia plays a minor yet essential role, assisting in various aspects of cement's behavior. Sulfur trioxide, present at around 1 to 3%, sulfur trioxide serves as a regulator, influencing setting times and other critical properties. Soda and potash, together, they constitute about 0.5 to 1.3%, adding unique properties to cement. When these ingredients are skillfully combined in precise proportions and mixed with water, they work in harmony, transforming a simple powder into the remarkable, strong, and durable material that is used extensively in construction. So, there you have it. Cement may not be the main attraction, but it's the backbone of our modern construction world. If you found this video informative, don't forget to hit that like button and subscribe for more fascinating insights into the world around us. Thanks for watching.